For half a century, astronomers have been looking for something that, according to every rule of physics we know, simply had to exist. And for half a century, it hid from every telescope pointed at it. That something is a wind, a hot outflow of material blasting away from the supermassive black hole at the very center of our own galaxy. In June 2026, a team at Northwestern University finally found it, and in doing so, closed one of the longest-running open questions in astrophysics. At the heart of the Milky Way sits Sagittarius A star, an object 4.3 million times the mass of our Sun, packed into a region small enough to fit inside the orbit of Venus. We know it's there because of the stars whipping around it at a meaningful fraction of the speed of light, work that won the 2020 Nobel Prize in Physics. We even have a direct image of the shadow it casts on the glowing gas around it, captured by the Event Horizon Telescope in 2022. But there's always been an awkward gap in the picture, a piece of basic black hole physics that refused to show up in the data. Welcome to Astrion X, where we go beyond the headlines and into the deep end of the cosmos. Today, we're looking at the discovery that finally filled in that gap, why it took 50 years and some genuinely clever detective work to find, and what it tells us about the quiet, unglamorous life of the black hole next door. Here's the problem astronomers have wrestled with since the 1970s. Black holes don't just pull matter in. According to decades of theory and observations of black holes elsewhere in the universe, any black hole that's actively feeding should also be pushing material back out. As gas spirals inward, it accelerates, heats up, and gets compressed, building up enormous pressure. Some of that gas never makes it across the event horizon at all. Instead, it gets flung back outward as a wind, or in more extreme cases, as a jet. This isn't a fringe idea. It's a basic consequence of how accretion works, and astronomers have observed these outflows around supermassive black holes in other galaxies for years. Sagittarius A star has always been the strange exception. Even though it's continuously fed by gas and stellar winds from stars in the surrounding region, nobody could find clear evidence that it was launching anything back out. Mark Gorski, a research astrophysicist at Northwestern who co-led the new study, put it simply: unless a black hole exists in a perfect vacuum, it has to blow some kind of wind, and there is no perfect vacuum anywhere in the universe. So the wind had to be there. The question was, why nobody could see it? Part of the answer is where we're sitting. Earth lies inside the disk of the Milky Way, which means that to study our own galaxy's center, astronomers have to look straight through the galactic plane, through thick layers of gas, dust, and ionized material that scatter and absorb the very signals they're trying to detect. Elena Merchikova, who co-led the study with Gorski, has described it as trying to see through a wall of static. Studying black holes in distant galaxies, seen from far outside their host disks, is in some ways easier than studying the one in our own backyard. The second part of the answer is that Sagittarius A star itself is unusually quiet. Most supermassive black holes only become bright and obvious during active feeding episodes, sometimes called their fireworks stage. Our galactic center's black hole spends most of its time doing the opposite, feeding gently and inefficiently, producing only faint signals that are easy to miss and hard to distinguish from noise. To finally crack it, Gorski and Merchikova turned to 5 years of extraordinarily deep observations from the Atacama Large Millimeter/Submillimeter Array, ALMA, high in the Chilean Andes. They used the radio array to trace carbon monoxide molecules, a classic marker for cold molecular gas, in the region within about 3 light-years of Sagittarius A star. Then came the hard part, carefully modeling and subtracting out the black hole's own bright, rapidly flickering radio glow, which had been drowning out the fainter structure around it in every previous attempt. The result was a map roughly 100 times deeper and 80 times sharper than anything made of this region before. And there, in that newly revealed detail, was a feature nobody had cleanly seen before: a vast, cone-shaped cavity nearly 3 light-years long and about 45 degrees wide, almost completely empty of cold gas and pointing directly back at the black hole. Something had hollowed it out, sweeping the cold gas aside or heating it until it stopped emitting the signal they were looking for. Stellar winds from the many young, massive stars orbiting nearby weren't nearly powerful enough to do this. Gorski and his team calculated the energy needed to carve out a cavity of that size and found it exceeded what all the surrounding stars combined could plausibly supply. The shape of the cone, tracing back to a single point at Sagittarius A star itself, left really only one explanation standing: an energetic wind launched by the black hole. Because a result this significant demanded serious scrutiny, the team didn't stop there. They cross-checked their cavity against archival X-ray data from NASA's Chandra X-ray Observatory, which had previously picked up bright, hot X-ray emission in roughly the same patch of sky. If the cavity really was carved out by a hot wind, that superheated gas should glow in X-rays exactly where the cold gas disappeared. It did, lining up with the ALMA data closely enough that Gorski has said the two independent datasets simply slotted in perfectly. That agreement between two completely different instruments, observing two completely different wavelengths, is what turned a striking image into a confirmed discovery, published in the astrophysical journal Letters. Based on how far the wind's effects reach into a nearby stream of ionized gas, the team estimates it has been blowing for at least 20,000 years. That's a blink of an eye on cosmic timescales, but a strong signal that this isn't a one-off event. It also isn't a particularly dramatic wind, as black hole winds go. Merchikova has noted that it's relatively gentle, and that its direction likely wanders over time as the feeding pattern around the black hole shifts. That gentleness is, in a way, the whole point. This discovery doesn't just confirm decades of theory about how feeding black holes behave, it also gives astronomers a genuinely rare thing: a close-up look at a supermassive black hole in its normal, quiet state, rather than the rare, dramatic outbursts that usually catch our attention. Most supermassive black holes across the universe spend the overwhelming majority of their lives exactly like this: dim, understated, gently pushing back against the material falling into them. We just don't usually get to study that quiet state up close because it's so much harder to detect than a flare-up. Sagittarius A star, sitting right at the center of our own galaxy, is close enough that even its faint whisper of a wind could finally be picked apart. It also puts to rest, at least for now, the idea that our own galactic center might behave fundamentally differently from every other galaxy we've studied. For 50 years, Sagittarius A star's apparent lack of an outflow was a genuine anomaly, one of the few pieces of evidence that didn't fit the standard black hole feeding picture. Now that anomaly is gone. Our black hole isn't unique, and by extension, neither is our position in the universe, sitting around an entirely ordinary supermassive black hole, quietly doing exactly what the physics always said it should. There's more work ahead. Astronomers want to know how this wind's strength and direction change over time, whether it connects to the flares and flickers Sagittarius A star is already known for, and whether similar deep, painstaking analysis could reveal comparably faint winds around other quiet galactic centers. But for now, a 50-year search has an answer, hiding in plain sight, just 3 light-years from the edge of the abyss. If you enjoyed unraveling this one with me, subscribe to Astron X for more stories from the edge of what we know about the universe. And let me know in the comments what mystery about our galactic center you'd like us to dig into next.